as I said, we'll go over a little bit of how you interact with AMP-PD datasets within the Google Cloud Platform. So as I mentioned earlier, there is a two-tiered model for data access. The clinical and data and the release metadata are available for all registered users. That gives you access to all of the data you would need to identify the cohorts that of interest and the subjects of interest, and it tells you what data is available in AMP-PD on those specific users. Then with an institutional signature, you can get Tier 2 access, which gives you access to the genetic data, including variant information and joint genotyping data. This is a listing of the Tier 1 data that's available in the system. It's broken up, as I said, into release metadata and into clinical assessments. As you see on release metadata, we have a number of tables. Two of interest are AMP-PD participants, which shows you all of the participant information. And then there's the AMP-PD case control table, which gives you additional information on those subjects. We also have inventory information for whole genome sequencing and RNA sequencing samples. Then under the clinical assessments, we have a number of tables of basic data like enrollment information, demographics information. Then we have a lot of medical history, including family medical history, caffeine, smoking, alcohol use. And then we have some imaging information available. And then we have a number of clinical assessment tables, things like the MOCA form, the MDS UPDRS, and a number of other forms that let you get information on specifically what symptoms people have, cognitive ability, things like that. Then in our Tier 2 data, there is additional clinical data. We have specific mutations that are known to relate to Parkinson's disease. So you can query, you can use that as your inclusion criteria for a cohort. We also have a lot of data on whole genome sequencing and a lot of data on the RNA sequencing, including, most importantly, queryable variant data. So going over the methodology that you would use in AMP-PD to identify subjects of interest. Again, as I mentioned, there are clinical assessments available, so you can find the subjects within AMP-PD that have the correct demographic profile and medical history. You can find the age at their baseline visit, whether they're case control, race and ethnicity information, lots of information like that. We also have medical history information, such as the age of diagnosis, what recent medications they're on, and again, alcohol and smoking history, caffeine use, lots of other environmental information. Once you've found the subjects that fit your demographic profile, we then have the diagnostic assessments that are used to find subjects that are applicable to your research. You can look at summary scores. You can look at scores for individual things like fatigue or memory recall, and a number of other things. There's also the release metadata. So if you're only interested in subjects for whom there is whole genome sequencing data available or RNA sequencing data available, you can limit your search to just those subjects. You can also, once you've figured out what it is that you're trying to look for, we've created a sort of a step-by-step process that you would go through for identifying particular subjects and creating a query to download that data. So the first thing, as I said, you would want to do is determine the identifying information required for the subjects and samples. What information do you need? Do you need the sample ID, the participant ID? Are you looking for GUID information? The next thing you would do is to identify your inclusion and exclusion criteria for the subject. What would you use to include them in your subject listing, and what would you use to exclude them? Then you would figure out what sample data you're looking for. Are you looking for particular mutations? Are you looking for all variants? Then having listed off all of the information you're looking for, you would use our data dictionaries to identify the tables that contain that information. So knowing that you want information on the a particular mutation, you could then go and search through our data dictionaries to find what tables contain that information. If you care about a particular score or a particular symptom, you could look for that in the clinical assessment forms. After doing that, then you need to identify the information that links those tables together. So to get to certain information about a particular whole genome sequence, a particular sample, you would need the sample ID. So you need to know how the tables are tied together, and you need to include that in your query so that it can correctly come back with the information. I'm now going to give a brief demonstration of a basic query. We're going to go through, we're going to look for subjects with particular demographic features. We're going to look for subjects with particular medical history. We're going to look for particular assessment scores, and then we're going to look for we're going to limit that to subjects who will have samples available. So again, in the Cloud Platform user interface, I'll pull up the BigQuery interface. And in here, I've saved the number of queries so we don't have to, so nobody has to watch me type them out. So the first query I'm going to show you is a select query that's just pulling the demographic information from our demographics table. So we're selecting visit name, visit month, age at baseline, sex, ethnicity, race, and educational level years from our demographics table. And the way we're locating that demographics table is it's in our AMP-PD research project. It's in our 2019 V1 release 1015 dataset, and that's our tier 1 dataset for our V1 release, and it's in our demographics table. So you'll see all of our tables are referenced this way, and anybody with access to the AMP-PD data can get to these from within their own cloud project. So now that we've got that query there, we'll run it, and hopefully this one will come out with some results. Oh, good. So when you run the query, it shows your results down here. In this case, there are 4,298 subjects that meet our criteria because we're just asking for all of the subjects that we have demographic information on. You can scroll down through them. You can browse from page to page through it. And then I will pull up our second query. So what we're going to do now is to build on this query that we've put in looking at the demographics information, and we're going to join that to pull up the initial diagnosis and the most recent diagnosis from the PD medical history table. So as you see, I've added these two additional pieces of information that we're looking for in our select statement. I've also added an additional table, the PD medical history table, in our from statement. And then in our where clause, I have to tell it how we want to link those two. So I want to get the information from PD medical history for only the subject that it's related to in the demographics table. So that's where this where clause comes in. And I only want the ones that have an initial diagnosis. If there was no diagnosis, I don't want to include those results. So here are the query results for this one. And as you can see, there are 2 more columns that have been added. We now have the initial diagnosis and the most recent diagnosis for these subjects. Now we're going to join that information to an assessment, a clinical assessment table. So opening that, what we're doing now, we have our same select query up here, but we've added another additional query. We want only the participants where their participant ID is in this list. And this list that we're getting is a list of all of the subjects from our MOCA table that have a MOCA total score greater than 24. So this will give us the same information as our previous query, but it's going to limit the results to only the ones who have a MOCA score of greater than 24. And so this is our result set here. So it's the same data, but we now know a lot more information about these people because of their summary score. Then the last thing we want to do is to look for only subjects that have a sample, that have sample data information available in our whole genome sequencing sample table. So that's adding this additional clause down here that says we only want participants who are in this list of participants from our WGS sample inventory table. And this gets us the same data as before, but now it's limited to only subjects with a MOCA score of greater than 24 who have a sample available sample data available in our whole genome sequencing data. So now I want to talk a little bit about exporting that data. Once you've gone through and you've narrowed down your query to produce the data that you're really interested in downloading, you can download that directly from the user interface, or you can download that using a command line tool. Again, as I showed you before, you can use the BigQuery function from a virtual machine, and you can send that out locally to a file, or you can send that directly into your processing scripts. If you're saving it from the BigQuery interface, you can save your data not just out to a file, but you can also save it to a bucket within your local project, or you can save it to your local machine, or you can create a new table from it in your own instance of BigQuery. So I'll quickly show how data can be exported. So this is the set of results from our query. If you use the save results function, you have to tell it how you want it saved. CSV format, most people are familiar with. You can also save it as a JSON object. A BigQuery table, you can save it out to Google Sheets if you want to do that, or you can copy the data to a clipboard if you want to paste it somewhere. So assuming you want to save it as a CSV file, so it will save it directly to a Google Drive, and now it's available there. Going back to our demonstration, that is all we wanted to present about querying the AMP-PD data. I'll open it up now if anybody has questions.
So we have one question that came in about the specifics about the data itself. The question is, do all the cohorts have MOCA data available, and are there any other cognitive tests available other than MMSE?
I'll pass this one off to Deb. She's going to be better at answering these questions.
Most of the cohorts have MoCA data. I believe the Harvard biomarker study used the MMSE. At the moment, that is the only cognitive test available in the AMPD data set. But again, you can go back to the original cohorts where some additional cognitive testing is available.